My guess is that you've probably heard of both acids and bases, even if it's even battery acids and baseball bases. Now, acids, you probably have a pretty good understanding of. When you think of acids, you think of things that are more sour or things that are more sticky, such as lemons or soda. Like when you spill soda, if you don't clean it up right away, it'll get really sticky and the floor will be sticky until you apply a base to it, such as soap. When you think of bases, it's things that are more bitter or slippery, such as egg whites or melons, or in that case, soap. Now, my guess is also that you've probably never heard of Lewis acids and bases. Now, Lewis acids and bases, it's a greater understanding than the Bronsted-Lowry theory. This is because G. N. Lewis, he wanted a greater description of it, of like protons and electrons. So he based his theory off of the structure and bonding of electrons. And through the theory from G. N. Lewis, chemists have been able to predict greater reactions, more extensive reactions off of elements. Now, you're probably thinking, what the heck is the Lewis acid and base theory? Well, basically, it's that acids accept electrons and bases donate electrons. What that means is that if an acid needs an electron, a base will give that acid an electron. Examples of acids are cations, such as copper, iron, or hydrogen. All of these elements need electrons, so bases will give the cations electrons so that they can have 8 and then they're both happy. Now, when a base donates an electron to an acid, this is known as a coordinate covalent bond. And this is displayed by an arrow rather than a line when you're drawing a Lewis structure. When a base gives up one of its electrons to an acid, this is known as an addition compound, or it can also be known as an adduct. Now, keeping all of those things in mind, you have the actual formula, which is where it gets kind of confusing. So, H2O gives this pair of electrons to sulfur in order for it to be happy, because right now it only has 2, 4, 6 electrons, but it needs 8. So, water gives sulfur 1, so that it has 8. And they're both happy. So now pretty much what you have to do is you have to create the final Lewis structure for the combined structures. So you're combining H2O and sulfur trioxide to make the final Lewis structure for the Lewis acids and bases. This kind of takes us back to a couple months ago when we were talking about Lewis structures. Bet you thought you wouldn't need all that information again. Well, you were wrong. So once water has given its needed electrons, this is what the structure looks like. This is the Lewis acid and base structure.